Hi, this is Suchi, and I'm back with another video in the NumPy series. And our today's topic is splitting. How to split a NumPy ND array into multiple sub-arrays. So let's look into the topic. First of all, our first task is to import the NumPy package into our code so that we can use all the classes methods which are defined under this package. So what we are doing, we are writing import NumPy and we are giving a short name to this NumPy package so that in our code, we can access all its methods, classes with this short name itself instead of writing NumPy every time. So let me execute this part. And now the NumPy package is accessible in our code with the short name in. Now let's go into the actual example. So here it is. Let's say we have an array like this. We have an array like this. This is nothing but an one-dimensional array where these are the index numbers. So these are nothing but the index. Okay. 0th index, 1 index, index number 2, index number 3, index number 4, index number 5. And these are the values 1, 2, 3, 4, 5, and 6. Okay. So we have 1, 2, 3, 4, 5, 6. Total 6 elements here in the array. And what we want to do is we want to split this array into multiple subarrays. To be specific, here we want it to be split into 3 subarrays. What are those 3 subarrays? This is one, this is another, and this is the third one. So we want it to be split in 3 subarrays where each array will have 2 elements. Because we have 6 elements, it is equally distributed into 3 subarrays having 2 elements each. So what we are doing, we are splitting it. Now, how we can do that? There is a simple method called array underscore split. So let us look into this. Here I am just defining one array with the 6 elements that we have seen in this visual example. Now, what we need to do is we need to use this NumPy method, which is array underscore split. So np.array underscore split, and then we are passing the array and the number of subarrays we want from it. So the number of splits we are specifying in the second parameter. So first parameter is the array, the ND array, and second parameter is number of splits we want. Now, let us execute this code and let us see what is the final result. So we can also print the actual array to understand it better. So the original one and then the result and also the return type of the result. Let us see. So the original array was not this one. This is the original one. So let me just change it. So the original array was nothing but this one, which is a simple one-dimensional array having 6 elements. Values are 1, 2, 3, 4, 5, 6. Now, when we are applying array underscore split, and we are splitting it into 3 parts, what it is returning us? It is returning 3 arrays, a list of 3 arrays. Why? We can see here the return type of this is nothing but a list. So if we execute type of a new array, what we are getting, it is a list. So it is nothing but a list of ND arrays. So what we can do, as it is a list, we can loop over this list and we can check individual elements also. So let us do that. Here I have written one loop where I have used enumerate to get the index number also. And then what I am printing the index number, the data type of individual item and the item values. So let us see what is being printed here. So here we can see the item number 0 is an ndarray and the item itself is 1, which we were expecting here. One ndarray with these two values. Another one, the item number at index 1 is again another ndarray and the values are 3, 4. Again, if we look at this one, at index number 2, we have another ndarray which is having these two elements 5, 6. So this one-dimensional array is split into 3 one-dimensional arrays. Note it very carefully. When one-dimensional array is splitted, it is returning a list of one-dimensional arrays. So here it was a one-dimensional array and we are getting a list of 3 one-dimensional arrays because we have specified the split number of splits as 3. Now, we might wonder that what if the number of elements of the array or the length size of the array is lesser than the number of splits. Here we are having 6 elements and we are splitting it into 3 arrays. So 6 divided by 3 is 2. So we can easily say that each of the arrays, each of the resultant subarrays will have two elements each, because 6 divided by 3 is 2. So 2 elements in each of the 3 arrays we will get. But what about we are having less number of elements in the array that we are specifying in the number of splits. So what will happen here? Let me copy the same loop over here, just for a better visibility. So first let me comment off this and let me execute this. So now we are having 3 elements in the original array and we have specified the split value or number of splits as 4. So what should happen? Will it return only 3 arrays with 1 elements each, or will it return 4 arrays? If so, then the last array or the 4th array, what it will have? Because we are having only 3 elements, so how it will be split into 4 arrays? So let us execute this part and see what happens. So this is the original array, as you can see, and it has been split into 4 arrays actually. So this is the first array which is having the first element. This is the second array which is having the second element. This is the third array which is having the third element. So what about the 4th array? 4th array is empty. Only the data type is visible, that is int32, because rest of the arrays are also having the same data. And it is interpreted based on the value over here. Now, what is the return type of this array split? Again, it is list, definitely. So this is a list of 4 empty arrays where these 3 elements are divided or distributed into 3 arrays, 3 of them, and the last array is empty because we are having only 3 elements and we wanted 4 splits. So this has become empty split. So what about if we have 5 splits? Definitely it will return 5 splits, but the rest of them where we are lacking the elements, those will be empty. Now if we just execute this, loop to check individual elements one by one, we can do that. So here we can see at 0th index we have ndarray and the item is nothing but one-dimensional array having one item which is what? First value. This is the second one. This is the third one. This is the 4th one which is empty. This is the 5th one which is empty. So this is how it works. Now, you might think Okay, that I understand. If the number of elements is lesser than the number of splits, then the rest of the results will be empty. But in this case, in the first case where we were seeing the number of elements is greater than the number of splits and it was divisible because this was 6 elements. There were 6 elements in this array and we are splitting it into 3 arrays. So we are getting 2 elements in each array. Now, if this size, the size of this array is not divisible by the split size, what will happen in that case? So how the elements will be distributed? Let us have a look into that scenario also. Here we are adding 7 elements, 1, 2, 3, 4, 5, 6, 5, 6, 7. And the number of splits is again 3. So if we do that, let us see what is the result. Because 7 is not divisible by 3, right? So how should the elements be distributed? Into 3 arrays. So let's execute this and we will see. Okay. So here you can see size of the array is 7, number of splits is 3. So we are getting 3 arrays, a list of 3 ND arrays as a result, and individual elements. So the first element is having 3 elements. First array is having 3 elements. Second array is having 2 elements, and third array is having last 2 elements. So this is how it is actually distributing the elements. So if the number is not properly divisible, the size is not properly divisible with the split size, it won't be an equal distribution of elements. And generally, from the left side, the arrays will have greater count of elements. So we can change it to 4 and see what happens. Here you can see, if we have changed it to 4, we are seeing 3 arrays with 2 elements each, and the last array is having a single element. Similarly, if we change it to 5, we can see these first 2 arrays are having 2 elements each, and the last 3 are having 1 elements each. So this is how the distribution happens. Now, let's look into a multi-dimensional array. So we have been talking about one-dimensional array all the way along. So if it is a case of one-dimensional array, it is very easy to imagine how it is going to be distributed. So this will be basically splitted with, if it is one-dimensional array, it is just going to be splitted like this along the first axis itself, right? But what about it is a multi-dimensional array? How it will be splitted? So let us look into this multi-dimensional array. We are checking for a multi-dimensional array here. This is the array. So let me just comment out the rest of the code. And let me print this array. To see how it looks like. So this is the array. And by looking at the array, you can see that there are 3 brackets at the starting, which clearly means that this is a 3-dimensional array. And to check that, validate that, we can also print the number of dimensions of the array, which is very easy to do, is array.ndim. So which will give us the number of dimensions here. We are getting it as number of dimension. We can see it is 3. So we are having a 3-dimensional array. So basically 3-dimensional array means there are 3 axes over here, and the axis numbers are 0, 1, and 3 axes. Along the first axis, okay, let us take the shape as well so that we will get a better idea. So how to check the shape? It's nothing but shape. So let us see what is the shape. Shape is 3, 2, 3. That means along the first dimension or along the first axis there are 3 elements. In the second axis there are 2 elements, and in the third axis there are 3 elements. So what is the first axis? This one. So if we see along this one, we are having 1, 2, and 3. 3 elements. Okay. Let me mark it so that we will understand it better. This is the first element, this is the second element, and this is the third element along the first axis. Now, along the next axis, which is the second axis, how many elements are there? 1, 2. So we can check individual elements of the first axis to identify how many elements are there along the second axis. So here we can see 1, 2, 2 elements are there. Here also you can see 1, 2, 2 elements are there in the second axis. That's what here we can see. It's 2. Now let us see along the third axis how many elements are there. 1, 2, 3. 3 elements are there. So the third axis is having 3 elements. That is how we can determine how many determine the shape of the ndarray. Now let us get into this particular task. So what we need to do, we need to split this array into 2 arrays, 2 sub-arrays. Now the split will happen along which axis? Axis 1, axis 0, axis 1 or axis 2. So by default, the split is going to be along the axis 0. Let us see. So this is our array. Now axis 0 is nothing but this one, outer array. So if we split this one is having 3 elements, 1, 2, and 3. 3 elements. Now if we split it into 2 arrays, 2 sub-arrays, how many elements will the first element, first element of the result? First sub-array will have 2 elements, 1, 2, these 2, and the second one will be having this one. If we split it into 2. So basically the split will happen like this. This will be the split. So this will be the first sub-array. This will be the first sub-array. And this will be the second sub-array. That is our intention. So if we just write np.arraySplit and pass this array and pass the split number of splits that we are expecting is as 2, then we will get the expected result. So let me just comment out this part. And I'll comment this for loop, which is iterating through the result that we are going to get, and it will be printing each elements. Before doing that, we will print the whole new array, which is the result of this operation. So let me again comment it out and print it first. So here we can see the new array is having 2 elements. First one is this one. First one is this one till here, and second one is this one. So let us print this individually so that we will understand it better. So let us see what happens when we run this. So the item number 0. Let us look into the item number 0. Item number 0 is an ND array, which is 2-dimensional, which is again 3-dimensional, because this original array was 3-dimensional. So as we have seen that when we split an 1-dimensional array, we are getting a list of multiple 1-dimensional arrays. So that same thing applies here. When we are splitting a 2-dimensional array, we will get a list of multiple 2-dimensional arrays. When we split 3-dimensional array, then we will get a list of multiple 3-dimensional arrays. So basically, whatever the original array's dimension is, number of dimension is, the resultant sub-arrays will also have the same number of dimensions. So here, that is why you are seeing we are having a 3-dimensional array, and the first dimension is having 2 elements, So let us print those informations also so that we will understand it better. It will help us understand. Dimension and shape. So let me just print item dot ending item dot shape. So here we go. We can see the first item, which is item number 0, is having 3 dimensions again, and the shape is 2, 2, 3, because the first dimension is having 2 elements, second one is having again 2 elements, 1, 2, or 1, 2, and the third dimension is having 3 elements, 1, 3, 1, 2, 3. So that's what our result is. So this is the first item where we are getting the first 2 elements, that is these 2. And in the second dimension, in the second one, the item number 1, we are seeing again dimension number is 3, but it is having shape of 1, 2, 3, where we are having only one element, which is nothing but this one, 13, 14, 15, 16, 17, 18, this one. So this is how we wanted it to be splitted along the first axis, axis number 0, to be very specific. Now, now our question is that now we know that we can actually split it along the first axis, right? We can split it along this axis, which is the axis 0. Correct. But now, what if we want to actually split it along this axis instead? This axis, which is axis 1. Okay, this is axis 1. So if we want to split it along axis 1, that means we want this part to be one array, and this part to be in another array. Can we do that? We can easily do that with the help of the third parameter that we can pass into this array split function. Let's look into the steps how we can do that. So here is another example with the same array which we were seeing here. The same array, we will just do a split. We are passing it to np.array underscore split, and we are passing the array, we are passing the number of splits we want, and finally we are passing the third parameter, which is nothing but axis parameter. So what if we don't pass the axis value? So we didn't pass the axis value here in the last example, previous example. What happened? It splitted along the 0th axis, which is nothing but this one, the outer array. But for the first dimension. So if we are going to assign 0, axis 0, that is nothing but the default behavior. So if we just assign it 0 here, and let me copy this part of code. What we can see? We can see the same result that we were seeing in the previous example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These two are here, and the second one is 13, 14, 15, 16, 17, 18. In this result also, we are seeing the same split, same distribution. Now, if we make it axis 1 to achieve what we were talking about regarding this one having into one subarray and this part to have into another subarray. So if we put axis as 1, we will see the thing that we were discussing about. So Let us execute this part and let's see what happens. So here we have executed this, and we can see that the first item, which is the item number 0, is again having a dimension 3. Shape is 3, 1, 3. So basically, we are having these 3 elements here, 1, 2, 3. You can see here 1, 2, 3, 7, 8, 9, and 13, 14, 15. These 3 elements here in the first array, and second subarray is again 3, 1, 3. This is the shape, and the dimension, number of dimension is 3. And here the items are 4, 5, 6, 10, 11, 12, 16, 17, 18. Nothing but these 3 elements. 4, 5, 6, 10, 11, 12, 16, 17, 18. So basically, if you look at the shape, then you will understand one more thing from here. So if we just print this, original array here, here you can see the shape is nothing but 3, 2, 3. So when we are splitting based on this shape or this axis, to be specific, when we are splitting based on this axis, 0th axis, what is happening? What is happening is this part is splitted into multiple subparts. So here, what we are doing, we are saying that split the axis 0, number of elements in axis 0, into 2 parts. So what is happening? This 3 is splitted into, this 3 is splitted. And what is the output we are getting here? If we see, the first shape is 2, 2, 3, and the second shape is 1, 2, 3. If we add it up, this first 0th index, 0th axis value, then it becomes 2 plus 1, 3. So this becomes again 3, 2, 3. If we add up the 0th index value of these 2 shapes. So basically, when we split along the 0th axis, the shape is splitted, or the shape is being distributed for the first index, and this part remains same. Okay, this part remains unchanged. Now, in the second case, what we are doing? We are actually splitting along axis 1, which is nothing but this one. This one. So what will happen? This is going to be splitted into 2. So now this part is going to be splitted into 2, which is 1 plus 1. So that is why what we are seeing over here is, if we look into the result of the second split, where we are specifying axis is 1, we are seeing over here is 3, 1, 3, 3, 1, 3. That is, the 2 here is splitted into 1 plus 1. Now, the next example, we will split over the axis number 2. So let's look into this. So this is the same array again. And if we want a split over axis number 2, that is, we want to split it like this. We want this part of this array to be into one array and this part into another array. So this is going to be split along axis 2. So how we can achieve that? Definitely, if we write axis value as 2, we can achieve that. And what is the result we are getting? Let us have a look into that. Let me just copy it and bring it over here. And let me execute this code so that we can see what is happening. So the first element. Here again, please remember the actual shape or the shape of the original array was 3 to 3, right? So the shape of the original array was 3 to 3. Let me print it also. Print shape of original array is what? ARR dot shape. Correct? So if we print it at the top, it will be helpful to understand. If we add a new line over here to increase the readability. So here we can see the shape of the original array was 3 to 3. And it has been splitted into, splitted along axis 1 into 2 parts. That is why it became 313 and 313. So this axis 1 is being splitted into 1 plus 1. Now for the third case scenario, what we are going to do? We can see we are actually splitting over axis 2, which is the third part of the shape. So this part has to be splitted into 2 plus 1 now. So if it has to be splitted into 2 plus 1, what is going to happen? Here we can see the first one is 3 to 2 and the second one should be 3 to 1, right? So the second one is 3 to 1. So the first part, which is this one, is unchanged because we are splitting over axis 2. So 0, 1, 2. This is the axis where we are splitting. That is why we are seeing here that 3, 2, 2 is the shape of the first element. And it is having this part, this left part of the thing. And again, if we go here, we can see 3, 2, 1 is the shape of the other array or other sub-array. And here we can see it is having the elements which we can see over here at this part, right part. So this is how we can change the axis value to manipulate how the array will be splitted. And the same thing will be applied to higher dimensions also. And along with the number of dimensions, the number of axes will also increase. So in case of 4-dimensional array, it will be, we can actually specify axis starting from 0 to 3 because there are 4 dimensions. So 4 axes should be there, 0, 1, 2, 3. And similarly, for the higher number of dimensions, the axis will keep increasing. Now, what will happen if we try to assign a value to the axis which is not present, which is greater than the dimension? So what will happen here if we do so? Here you can see we are getting an index error because this is a 3-dimensional array and axis number 3 does not actually exist. So that is why we are getting an index error while we are trying to split it over an axis which does not exist at all. Cool. So this is it for today, guys. We will talk more on ND arrays in our next video. Till then, keep learning, keep implementing. Thank you for watching.